Welcome to the second video of Chapter 11, which covers areas of trapezoids, not parallelograms. We've already done those, so if you would cross this out, it should be trapezoids, rhombuses, and kites. Parallelograms and triangles we did in the last video. So these objectives are also wrong. I'm sorry for the mistake. This video will cover trapezoids, rhombuses, and kites. We're going to calculate their area, and then like last video, I might give you the area and ask you to work backwards to find a missing side or angle. Before we do anything, we should probably talk about what are the area formulas. Well, the area of a trapezoid is 1/2 height, base 1 add base 2. So in our figure here, we have one base, we have another base, and your height is going to be the perpendicular distance between those bases. It's really important to remember that your height always has to be perpendicular. So in example 1, it says find the area of the figure below. Well, this is a trapezoid, so my formula is 1/2 height, base 1 add base 2. In this case, my height is the one that's perpendicular. This side is perpendicular, we can see by the right angle, so my height is 4. My two bases are connected by the height, so 6 and 8. Okay, 1/2 times 4 is 2. 6 add 8 is 14. So my area is 2 multiplied by 14. My area becomes 28 feet squared. Remember, area always has units squared. And that's it. That was our first problem. So as you will notice, this formula is certainly a little more complicated than parallelograms and triangles, and involves 3 quantities, both bases and the height. Okay, we're going to go on to example 2 now. Example 2 says trapezoid ABCD has bases of lengths 17 and 31. The area of ABCD is 624 centimeters squared. Find the height. I would like you to pause the video and try this one on your own, please. Give yourself about 1.5 minutes, 2 minutes, set up the problem, and solve for the height. Good luck. Okay, let's see how we did. Remember that the area of a trapezoid is 1/2 height, base 1 add base 2. We are told the area is 624, so 624 is equal to 1/2 height. My bases are 17 and 31, so 17 add 31. This becomes 624 equals 1/2 height. 17 add 31 is going to be 48. Now, at this point, you have 2 options. You could take 1/2 of 48, or you could multiply by both sides to get rid of the 1/2. I'm going to multiply the 1/2 and the 48. So really, all I'm doing is I'm switching that 48 and the h. So 1/2 48 multiplied by h. That's all I'm doing, and I can do that because of the commutative property. I can flip the 2 variables when I'm multiplying. Now, half of 48 is going to be 24, so the right side becomes 24h. Once I divide by 24, I get h equals 26 centimeters. So the height of my trapezoid is 26 centimeters. Now, we're going to pause that for right now. That's areas of trapezoids, and we're going to move on to rhombuses and kites. So the area of a rhombus and a kite, so this formula applies to both, is 1/2 diagonal 1 multiplied by diagonal 2. So here in this formula, D stands for diagonal. So in the case of this kite that we are given, remember a kite has 2 pairs of consecutive congruent sides. My area would be 1/2 one diagonal, which is LN, multiplied by the other diagonal, which is OM. And this also applies to rhombuses. Remember, the rhombus has 4 congruent sides. So just drawing us a little picture of a rhombus. It's kind of like a smushed square. All 4 sides are congruent. So same formula applies to a rhombus as does a kite. Because the formula involves diagonals, I want to quickly remind us of some of the diagonal properties. So if you would flip the page, please. Okay, so I want to again remind us of some of these diagonal properties of a rhombus and a kite. So starting off with a rhombus. The diagonals are perpendicular. The diagonals bisect each other. And then the diagonals bisect the opposite angles. So drawing us a quick little sketch. Rhombus, so all four sides are congruent. So the first property is that the diagonals are perpendicular. So I draw them in, they form a right angle. Okay, they also bisect each other. So that means one diagonal is bisected, the other diagonal is bisected. And then the last property is that they bisect the opposite angles. So this angle is bisected, this angle is bisected, that angle is bisected, and that angle is bisected. That was just to give you a quick little refresher, but those three important properties are going to come into play later in this section with some more difficult problems. So it's really important that you remember those. Now onto a kite. Diagonals are still perpendicular. Second property is that one diagonal bisects the other diagonal. So only one diagonal is bisected, the other one is not. And then one diagonal bisects the opposite angles. So these properties are definitely a little more difficult because they only apply to one diagonal each. So if I have my kite, I have one pair of congruent sides, another pair of congruent sides. Now looking at what these properties are going to look like. Diagonals are perpendicular. So here are my two diagonals. They are perpendicular. One diagonal bisects the other. So this diagonal is the one that's bisected. The other diagonal is not bisected. The diagonal that's bisected, the diagonal that's not bisected, bisects the opposite angles. So these angles are bisected, and then this angle is also bisected. Okay, important to remember, and we talked about this in Chapter 8, the diagonal that's bisected is the one that connects the non-congruent sides. So these sides are not congruent. This diagonal then is the one that's bisected. The angles that are bisected are the ones that connect the congruent sides. So hopefully you remember that. If not, please make sure you bring it up in class because that's pretty important. So looking at example 3, it says in kite LMNO, LN is 14 feet, MO is 12 feet. Find the area. Well, before we do anything, we should probably draw a figure. So I have a kite. It's LMNO. Remember, it does not matter where you put the L, but you do need to go in order from that point. So I generally go clockwise. So put your first point and then go clockwise with the other three. We are told LN is 14 and MO is 12. So area of a kite is 1/2 diagonal 1 multiplied by diagonal 2. In this case, one diagonal is 14, the other diagonal is 12. So 14 multiplied by 12 ends up being 168. If I multiply that by 1/2, I get the area to be 84 feet squared. So that's not too bad. Okay, we're going to move on to example 4. It It says one diagonal of a kite is 3 times as long as the other diagonal. If the area of the kite is 216 square inches, what are the lengths of the diagonals? I would like you to take a minute, pause the video, and try this one on your own, please. Good luck. Okay, let's see how we did. So we have 2 diagonals, diagonal 1 and diagonal 2. We are told one diagonal is 3 times as long as the other. So one diagonal is x. The other one is 3 times as long. So the other one is going to be 3x. Now remember, area of a kite is 1/2 diagonal 1 multiplied by diagonal 2. Our area is 216. That's 1/2. Diagonal 1 is x. Diagonal 2 is 3x. So I have 216 equals 1/2. X multiplied by 3x is 3x squared. Now I'm going to multiply the 1/2 and the 3, and I get 1.5x squared, and then 216 stays. Now I'm going to divide both sides by 1.5. I get 144 equals x squared. If I take the square root, hopefully you remember that the square root of 144 is 12. So it says, what are the lengths of the diagonals? Well, one diagonal is 12 inches. That's the x. The other one is 3 times as long, 3x. So it's going to be 36 inches. So my diagonals are 12 and 36. As a little bit of a check, my area would be 1/2 diagonal 1 times diagonal 2. So this is 1/2. 12 multiplied by 36 is 432. Half of that ends up being 216, which is what we were given in the problem, so our answer checks out. So hopefully you did well on that one. You should be getting better at these. We'll be doing more and more of these problems as the chapter goes on, where it gives you the area and then it compares one quantity to another. So if you're not very good at these, that's okay, but please make sure that you ask for help when you need it. Okay, let's look at example 5. It says the area of rhombus FIJG is 64. If IH is 2, find FH. Okay, so we need to remember back to some of those properties of rhombuses. First thing, I know that the diagonals are perpendicular. I know that they bisect each other. So this little part is congruent to that one, this little part is congruent to that one. So that helped me right now. If IH is 2, then HG also has to be 2. We are asked to find FH, so I'm going to mark that X. Well, if FH is X, then HJ is also X. Now this looks like I'm getting somewhere. The area of a rhombus, like a kite, is 1/2 diagonal 1 multiplied by diagonal 2. Now my area is 64. That's 1/2. Diagonal IG is 4. It's just 2 add 2. And then diagonal 2, which is FJ, is going to be X add X, which is 2X. And now I just need to simplify and solve. So I have 64 equals 1/2 multiplied by 4 is 2. So I have 2 multiplied by 2x. I get 64 equals 4x. If I divide both sides by 4, I get x equals 16. So in this case, FH equals 16 centimeters. So that wasn't too bad. All you need to do is you really need to think about those properties. The properties of the diagonals are so important. So a lot of times, in this case, we weren't given very much information, but we were able to find out a lot because of the properties of diagonals. Okay, let's move on. It says calculate the area of the figure below. Now, initially this looks like a trapezoid. The area of a trapezoid is 1/2 height, base 1 add base 2. I have the height, I have one base, but I don't have the other one. My first suggestion would be to draw a height in over here. If one height is 20, the other height is also going to be 20. And then that 21 also comes down. Really what you need is this right here. So right now, take 2 minutes, pause the video, and try this one on your own, please. Good luck. Okay, let's see how we did. Now, in order to find this little part right here, I have a right triangle. So I'm going to do Pythagorean theorem. I have 20 squared. Add x squared equals 29 squared. Simplifying, I get x squared equals 441, and x equals 21. So you should have been able to do that at a minimum. From here, I'm guessing you did one of two things. You could have found the area of the trapezoid, or you could have found the area of the rectangle on the left and added the triangle on the right. I'm going to do that. So the rectangle is base multiplied by height. The base is 21, the height is 20. When I multiply those, I get an area of 420. Triangle is 1/2 base times height. The base is x, which I just found to be 21. The height is 20. It's the same as the height of the rectangle. This ends up being 210. Now when I add them, I get the total area to be 630 units squared. This also would work the same way if you just use the trapezoid formula. So 1/2, my height is 20, my base, 1, is 21, this base up here. Base 2 is this entire base. So 21 add x, which is 21. So 21 add 21 is going to be 42. This ends up simplifying to 630. So either way, whether you looked at the rectangle and the triangle or whether you looked at the entire trapezoid, you should have gotten an answer of 630. If you didn't, that's okay. Hopefully you now see what mistake you made. If you have any questions, again, please make sure you bring them to class. We have one more problem to do, if you will please flip the page. Okay, so it says, did we accomplish the objectives? Well, we already talked about how I had the wrong objectives. So this video should have taught us about areas of trapezoids, rhombuses, and kites. Remember, trapezoid is 1/2 height multiplied by base 1 add base 2. Rhombuses and kites have the same area formula. It's 1/2 diagonal 1 multiplied by diagonal 2. So to test to see if we really understand what we're doing, we have one last question. You are making a flower decoration for your house in the shape of a kite. The area of the decoration is 450 square centimeters, and the length of one diagonal is 25. Find the length of the other diagonal. So this is where I'm going to leave you to do this one on your own. If you have any questions, look back in the video, look back at your notes, and good luck. I'll see you tomorrow.